Now we're on 8.3, multiple bonds. So in this section, we are going to describe multiple covalent bonding in terms of atomic orbital overlap and relate the concept of resonance to pi bonding and electron delocalization. So we've already talked a lot about our sigma bonds made from the overlap of p orbitals and s orbitals. And we briefly touched on pi bonds, that the additional electrons that are in a multi-bond are a result of side-by-side overlap of two regular p orbitals. So there's no hybridization. If you have a single bond, you have one sigma bond. A double bond has one sigma, one pi. A triple bond has one sigma, two pi bonds. So here's an example. This is the Lewis structure for ethene. And we can see that each carbon has a trigonal planar geometry. They're sp2. Okay, so there's both a sigma bond and a pi bond from the overlaps. So if we look at the orbitals in the carbon in ethene, each carbon is sp2 hybridized. And the sp2 orbitals and the p orbital are singly occupied. So those hybrid orbitals are going to form our single bonds, and then the p orbitals on the carbon are going to overlap to form their pi bond. So this is what happens once we start getting the orbital overlap. So we get one carbon-carbon sigma bond from the sp2 orbitals overlapping with each other. And then the two carbons each have these unhybridized p orbitals that then are attracted to each other and overlap side by side, and that's what forms one pi bond. So the two orbitals overlapping forms one pi bond. And notice they are above and below. They are not touching our axes here. So we talked about how sigma bonds can rotate. They allow the atoms in that bond to rotate. But in pi bonds, if they were to rotate, then you're going to alter that overlap that's happening and break the bonds. So rotation does not happen in a pi bond. Okay, and like we said, the lobes of the pi bond are above and below the plane of our sigma bond, or the sigma system, if you will. And remember, we talked about resonance before, and these occur when we have various arrangements of pi bonds that are possible. Remember, they're unhybridized, so resonance does not influence hybridization assignments. And if you need to figure out hybridization in molecules with multi-bonds, remember that a double or triple bond still represents one region of electron density. So this is just showing the hybrid orbitals of the carbon and then the unhybridized p orbitals of a carbon. Another example is benzene. When in organic chemistry, benzene is very, very popular. You'll be working with benzene rings. As a matter of fact, another way to draw the benzene structure with the resonance is, instead of showing the two going back and forth, you just draw a circle in the center. But each carbon is sp2 hybridized in the benzene structure. It doesn't matter which resonance form is considered. They're still sp2. The pi bonds are not located in one set of p orbitals or the other. They're delocalized throughout the molecule. So that's why sometimes we draw it with just a circle in the center. So the next thing we're going to look at, next figure, or we looked at figure 8.25. It shows the overall outline of the bonds in C2H2. Okay, so we'll be looking at that next, and this is a triple bond. So we're going to look at what the pi bonds look like in this. So this is a triple bond now. We have our single sigma bond in the center between the two carbons, and then one pi bond with a blue. Each pi bond has a blue and a red lobe. So that's what's happening there. So you see there's two pi bonds now perpendicular to each other and to the axis. So here's a quick example. Acid rain can result from the reaction of sulfur dioxide with atmospheric water vapor, followed by the formation of sulfuric acid. Sulfur dioxide is a major component of volcanic gases, as well as a product of the combustion of sulfur-containing coal. What is the hybridization of the sulfur atom in SO2? So this is actually a major problem on the East Coast, where there's a lot of coal burning. So that's why this is kind of an important thing to understand. You got the air quality person here, so I will get on my soapbox sometimes. So when we look at the sulfurs, remember resonance does not affect hybridization. So when we look at these sulfurs, we see that they have 1, 2, 3 regions of electron density. So therefore we have trigonal planar and sp2.